Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 5, Section 5, Inequalities in Triangles. So we start out with a property that can be used in geometry but is really based in algebra. And it says that if A is equal to B plus C and C is greater than 0, then A has to be bigger than B. So this one makes sense when you think about it. So if A equals B plus C, and we know that C is greater than 0, so it's positive, so we're adding a positive number to B. Then in order for A to be equal to B plus C, A has to be bigger than B. So we'll prove this one. It is going to be an indirect proof. So we'll do that in class. The next thing we have is the corollary to the triangle exterior angle theorem. We had the triangle exterior angle theorem earlier. It's the one that said that the exterior angle of a triangle is equal to the sum of the two remote interior angles. So this one is saying that, well, the measure of an exterior angle is greater than either of the remote interior angles. So this is based on the inequality theorem. So if we know the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3, and neither angle 2 nor angle 3 can have a measure of 0, then we know that the measure of angle 1 has to be bigger than the measure of angle 2, and the measure of angle 1 also has to be bigger than the measure of angle 3. So in this diagram, we're told that the measure of angle 2 equals the measure of angle 1 by the isosceles triangle theorem. And they want you to explain, so not prove, just explain why the measure of angle 2 is greater than the measure of angle 3. So if you take a look at the picture, we've got a triangle here, OPT, and angle 1 is the exterior angle for that triangle. So we know that the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. But we also know by the isosceles triangle theorem that 1 is congruent to 2, so the measure of 1 equals the measure of 2. So we can substitute, and we could say that the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. But we know that the measure of angle 4 can't be 0, and we know it's got to be positive. So if the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4, then the measure of angle 2 has to be bigger than the measure of angle 3. The next theorem we have says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So we can actually use this theorem to rank angles from shortest to longest. So first let's give this a name. We can't call it like the triangle inequality theorem because that's going to be later. So we'll call this the triangle angle inequality theorem. So even though you can see this one's the shortest and you can see the middle, I'm just going to label these. So this is the shortest. This is the middle. And this is the longest. So based on this, the shortest side should be, or shortest angle should be across from the shortest side. So we can say angle Z is less than, well, the angle that's across from the middle side, so that'd be angle X. And that's even got to be smaller than the angle that's across from the longest side. So that's angle Y. So we can use this theorem to rank all the angles from shortest to longest. And this one has a converse, so this is the converse of the triangle angle inequality theorem. And this one says that if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So if I label the angles, so I say that this is the smallest, and this is the middle, and this is the largest. Then now I can actually rank the sides from smallest to largest. So the smallest side would be across from B, and that's going to be less than the one that's across from the middle, so that would be AB, and that's even going to be smaller than the one that's across from the largest angle, and that's A, so BC. And the last theorem I have here is the triangle inequality theorem. This is I think out of the ones we've done, this is the most important one, and in class we'll talk about how we can actually use this theorem to come up with an idea of, okay, I give you 3 side lengths. Will it form a triangle? So this one says the sum of the lengths of any 2 sides of a triangle is greater than the lengths of the third side. So this one says that suppose I give you 2 side lengths. I tell you one is 6 and one is 11. Okay. If I add those 2 sides, that has to be bigger than the third side. So if I add 6 and 11, I get 17. So 17 has to be bigger than that third side. It can be anything smaller than that. And the reason for this is if I make something that's bigger than that, so maybe I make it 20, what's going to happen is this side's not going to be able to go over and reach that vertex. Okay? It's going to end up coming to about here, and now we've got like a straight line and it doesn't even reach. Okay? So that third side has to be less than the sum so that you can get the triangle to happen. And using this theorem, you can actually, I can list 3 sides. I can say 4, 8, 5, and you can tell me whether that would form a triangle or whether it would not form a triangle. So what we're going to do in class is we're going to take this triangle that's at the bottom, and we're going to write out all the inequalities and see that we can actually put them together and come up with a statement about when a triangle exists and when a triangle would not exist. Okay, so that's it for today's notes.